Okay, today we are going over the quiz 4 preview for a quiz tomorrow, and we are also going to be doing the lesson on solving equations with radicals. So I had mentioned this factorization yesterday as 6x plus 9 times 6x minus 9, which is not fully factored. Okay, so this is not done. Okay, so we could have done it this way, which would give us this correct answer. All right, that is the fully factored form. So this is the correct answer. Why is this not fully factored? Is because there is a common factor. So I proved it here with my other class today on second hour and discussed with them how I had not taken out the 3 here and the 3 here. So literally the first thing would have been, we could have started off the problem looking at 36 and 81. And the first step to any factoring of a problem is to check if all terms divide by a common number. This is a common factor of 99 between 36 and 81, so I should have actually factored out the 9 first. And then I would factor the difference of perfect squares of 4x squared minus 9. Okay? Anyway, follow how it gets here now? Any other questions about factoring here? And I know I had discussed this one with you. I started because actually it would be these two would be the most missed, like a half a point or whatever. But this one, a lot of kids miss because they totally space it and forget about that greatest common factor concept being the first thing to look for. Okay, so there was a monomial factorization on that one. All right. Check the answers here if you have any questions, and this could be either one of those. That is an or. Questions on 7, 8, 9, or 10, please? No? All right. This is not time to copy the answers down, as you should have already done this, so I'm hoping that you are just checking. If you need to write one down, obviously I don't care. I'm not going to, you certainly may do so. Hopefully you're just checking though, and this isn't like I'm trying to get all the work and show. You're not supposed to be having time to just fill all this in unless you're watching the video. But would I have one here you'd like me to do from scratch? I can do that. Yes. The 13. The rule is the same as the rule was for these in that, well, except they are a little different. So this one is, if you wanted to think of it as a power of a power or the root, remember the root is the index here, and you do, remember how I told you power over root, like a tree? So the power is the 15. You could rewrite this as 15 over 5, the root on the bottom, and then just reduce it. Is that good? Or just think 5 goes into 15 3 times, boom. All right, here's the answers for 14, 15, 16, and 17. They are circled. If you want me to explain one of those, I'd be happy to go over it. Scott? I figured that was coming. On 17, kids get, well, this is a cube root, which means we're looking for triples, not pairs. Did you understand 15? We're going with 15, guys? Okay, well, it's like 15, except it's harder to see what the number is because 360 is not a perfect cube. So I got to go to my perfect cube table if I want to figure it out. And here are my options. In the perfect cubes, you got 2 to the third, which would be 8, 3 to the third, 27, 4 to the third, 64, 5 to the third, 125, etc. One of those might divide into 360. So here's how I do it when I don't know, because I don't know. Go like this. Let's prime factor it, okay? So if I cut 360 in half, I often do that. What would 360 divided by 2 be? 180? So 2 times 180, but then I could cut 180 in half, so that'd be 2 times 2 times 90. And then I can cut 90 in half, so I do 2 times 2 times 2 times 45. And I see triple. See the triple? soon as you get 3, that's the answer that comes out. I'm trying to teach it another way today. I'm bringing up another way to think of it. So if you got 3 of a kind, you can rewrite this as 2 to the 3rd times 45, x to the 4th, y to the 7th. And you don't have to write this step because you're going to take the cube root of 2 to the 3rd, which is 2. Oh, I forgot to get the rest out before I make that radical. Then I do my rule for rational exponents and divide 3 into 4 evenly once to bring out an x. I divide 3 into 7 evenly twice, and I bring out a y, the y squared. And then I know I have something stuck under there, which is the cube root of, and I got the 45 still under there, because it doesn't break down to anything that's a perfect cube times a non-perfect cube. It just breaks down to 5 times 9. So that's why this mess is left in there. And the 2 times 2 times 2 was actually 8, which is the perfect cube number we're actually dividing, taking out. All right, so then I have an x left and a y left, because they did not divide evenly by the index of 3. There were remainders of 1. Are we good now? Maybe that gives you some insight into how to figure out what to pull out. We're break it down into prime factors, which is just divide by 2 or 3 and just keep on factoring. All right, next one. By the way, I got to slide this because I don't know what happened, but here, let me fix this so it actually looks like it's supposed to. I think this goes, let's see, what? Put in 0, you get -2, but it's got to go up to there. So I think it went like this. Kind of a weird way to show the answer, I know. Is that right? The steps are 2 apart. Does anybody want me to go over the step function? Okay, little steps. And then the second one, let's see, if you put in 0, you get 3, so that's not it. Oh, there, it must be that. Make sure I can tell your open holes are on the right and that your solid dots are on the left and that you have connected them. If there's just dots and holes, it's going to be wrong. These are steps. There are points in between here. Steps. Questions on step function? Want me to graph it? No? All right. There's your your piecewise graph. Shall I do this one? These are simply 2 linear graphs, only a part of them gets graphed. So a piece of one line, piece of another line. What I said for you to do was to graph, or first make a t-chart for each, or let's start with the first one. Let's do a t-chart for the first section. And we're going to be using this to make it. And it says when values of x are less than 1, which I allowed you to highlight, but this is not part of the graph, so it really shouldn't be on here, but if you use highlighter, I don't care. But you really should not be making a pencil line from there to there. It's like all solid. It's not part of the graph. Okay, so if you dash it up with a pencil, that's okay. Well, I want you to realize it's definitely not part of the graph. Okay, so then I go and I plug in the boundary number of 1. And I put in -1 plus 2, and that answer is 1. So I know at 1, 1, I have a solid dot. And why is it solid? It's because the inequality symbol says less than or equal to at 1. So then I put a number less than 1, which is 0. And I get 0 plus 2, which is 2. And I plot the point 0, 2. And then I can put in another number less than 1, would be -1. And then I put in -1, and I'd actually get 3. And I realized that that line has a slope of down 1, right 1. So I'm going to go reverse that, go up 1, left 1, and back it up. Because the part of the line we're supposed to be graphing is to the left, where values of x are less than 1, which means, or equal to 1. And that's the part of the domain this piece is covering. Now, once I'm done with the left part of the domain, I'm going to do the right part. So I'm going to go and just change colors so you can see where I'm going. And I'm going to plug in 1, because I need to know where the open hole is. All right, so this is going to be where I put an open point. The rest of the points, guys, on the graph aren't open. It's only the beginning of it. The rest of them are solid lines. The rest, I've been getting people putting dots or holes. They aren't a bunch of holes. The only hole is at 1. So I put in 1 in there. 3/2 times 1 minus 1 would be negative, not negative, but 0.5, right? 1.5 is a hole right there. So that's your open. Oh, I don't want to write it like that because I forgot the graph goes up there. All right, so if you want to note it because you have trouble drawing it, and I did too, but I got a red pen, open. All right, now I'm going to plug something in that's bigger than 1. Do we need? Plug in 2. So if I do 3/2 times 2 now minus 1, that would be 3 minus 1, which is 2. So at 2, I put a point. Maybe I'll put in another number bigger than 1, like 3. Oh, 3 is going to be gross. I don't want to put 3 in. What you need, Trey? You have to plug in 1, else you don't know where to start. If you don't plug in 1, you're missing part of it. Because that is the boundary number. You've got to know where that is, because that is everything just a smidgen past it is included. So if you only put in 2 and you start your line here, you don't have everything, and you will get marked off a point. So I'll go ahead. I'm glad you asked me that because I did note that on a quiz. I saw that happen to some people. If you plugged in 4, you would be doing 3/2 times 4 minus 1. That'd be 6 minus 1, which is 5. Or just realize that the slope of this is up 3, right, too? And there's that point, 4, 5. And then 1, 2, 3, right, 2. And then I just make my line. But see, you got to go to here. So anyone who forgets to plug in 1, and that's how I taught it from the very beginning. I said every single time you plug in the number, whether it's included or not, because that tells you your open hole, your discontinuity. If I forgot what I was saying just now, but if you hadn't put that in, this is what your graph would have looked like, right? You would have been missing part of the graph. So someone with this is getting marked off. It's got to show that you had to go to here. That's part of it right there. You're missing that whole piece. I think you got it now, right? I beat it to death. All right, next section. Tell me if you need me to do one of these. Remember that greater than is or, and less than is and. You must divide by 3 first. And then write the equations. You can't distribute the 3. Just don't do it. Isolate it first by dividing by 3. Do you have a question? Okay, how are we doing? Anybody need anything from this page? Otherwise, I should just go on. All right, bingo. How about this? Okay, that was it. All right, now we're going to go to solving radical equations. So I'm going to pause a moment while I pass out your final pieces of your unit. All right, we're going to solving radical equations is the topic. I said we're going to learn after this. It is solving radical equations is the exact opposite of solving power equations. So you have done x squared equals 36 before. What did you do? Took the square root of both sides and you said, but because this is squared, it could be plus or minus, and you got an answer of x equals plus or minus 6. Right? You remember that? You did this before. Oh, sorry, but you have. You're supposed to know that. Anyway, we'll review it. Maybe that's why we had trouble with that old parabola on the last quiz, because that's why it looks like a parabola, because of the plus or minus part. It has symmetry, okay? So anyway, let's not worry about what the graph looks like. Let's review this. So if you have 1/2 x squared minus 5, you would do 1/2 x squared equals, because you would add 5 to both sides, you'd have 18. And then you would multiply both sides by 2, which would give you x squared is equal to 36. And I just told you how to solve that problem. You would solve it by taking the square root of x squared, and it would be plus or minus the square root of 36. And then you would tell me that x is plus or minus 6. Okay, that's supposed to be review. Yes. Positive or negative. No, I just wrote it, Kai. 6 or negative 6 is what it means. Okay, 2 solutions. So this one's going to have 2 solutions because it has a squared power, a power of 2. So to solve it, you did the square root of both sides, which would be plus or minus the square root of 4. You understand now what I'm doing? I'm trying to write 2 answers concisely. Okay, positive and negative. So this would be x minus 1 equals positive or negative 2. And then you would add 1. And then you would say 1 plus or minus 2. And you would not leave it like that. You would simplify it. So 1 plus 2 is 3. And 1 minus 2 is negative 1. Those are your 2 solutions. Comma, or you can write the word or. Okay, there's 2 answers. Yes, you did this in Algebra 1. You guys graph parabolas. Algebra 1. Okay, guys, I'm not going to worry about complaining about it. We need to try to just get a refresher right now. It's okay. But you did graph parabolas in Algebra 1. Sorry. Well, then I don't know where you had it because our school teaches that. And no one said one thing that they didn't learn it in my second period, so I don't get it. Yes, ma'am. Go ahead. Okay, I'm finding out some major gaps at the moment, which I'm going to be correcting. I'm okay with that. So let me explain. I'm feeling bad because I'm supposed to be able to assume you've seen this before. So I'm not going to assume right now. I'm going to say this solution is, there's 2 of them. This means positive or negative 2. If I have to add 1 to both sides, what difference does it make where I add it? So I just did it in the front because this would mean 2. You can do this. Plus or minus 2 plus 1. That's positive 2 plus 1, which is 3. And negative 2 plus 1, which is negative 1. Okay? I just thought it was easier to write the 1 first. And also, you've done the quadratic formula. So if you've never seen the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, you're not telling the truth if you had Algebra 1. I'm not telling, okay, can you just stop for a minute now? This is something you have done in Algebra 1. It is in the course Algebra 1. I don't know who you had, and I'm not going to talk about that right now. I'm not telling you should know this right now and remember it, okay? I'm not. I'm going to be reteaching that again. But this is supposed to be something you've had experience with, so I'll talk to you guys about it later, if you will, please. We're going to go on to solving these. It's not that bad. Yes, Kai? When you have a problem with an x squared, or an a squared, or a b squared, or a c squared, or a y squared, c, w, n, and you're solving it has two things you can square to get a positive number. Would you agree with me that -3 squared, I mean, this you have to agree because otherwise you didn't have Algebra 1 or pre-algebra, that -3 squared is positive 9. And so is 3 squared. Okay, that's why a problem that has a variable squared has two possible solutions. Okay, does that make sense, I hope? So I'm going back a little bit to explain why, and I don't mind. It's just that I'm not going to get attacked until you didn't hear it before, because you really have. You just might not remember, and I need to refresh your memories, okay? So if I have a squared variable, there's two possible numbers that you can square to get whatever's over here, okay? Now, let's go on, and I'll try to do some remediation if necessary with you if you need to come in or whatever it is we need to do. Okay, but let's continue, please. I hope they answered your question, Kai. If not, I'll try to do it again at another time. Solve radical equations. So the following steps are used in solving equations that have variables in the radicand. Some algebraic procedures may be needed before you use these steps. So first you want to do that. I've told you how many times to isolate things. Isolate the absolute value. Now we're going to be isolating the radical. To eliminate the radical, raise each side of the equation to a power to the index of the radical. Remember what the index is? It's that little number that goes in that little crook. That thing's the index. You're going to raise it to a power that'll undo it. It's like I already talked to you about. X squared key on your calculator. Above it is the square root because the square root is an index of 2. They undo each other. They're inverse operations. Okay, so we want to solve the resulting equation and check your solution to make sure you haven't obtained any extraneous roots. Okay, back in Algebra 1, one more time. You're trying to tell, some of you are trying to say that you never graphed anything that looked like that, and that makes me crazy. That's not true that you didn't graph anything that looked like that ever or solve any, but that's what solutions are, and we're going to have a whole unit on quadratics. So I'm going to read the whole dang thing anyway, okay? All kinds of it, all ways to do it, all of it. That's coming up next. So you have probably graphed something that looked like this, a U, all right? And those are the two answers. And they have symmetry with respect to this at this time for this drawing, okay? They don't always. So I'll teach you all about it later. But anyway, example 1, this lovely example. The first thing they did was add 4, then they divided by 2, and then they squared both sides, and then they subtracted 8, and then they divided by 4, and they finally got to the answer of 7. Okay? And they were supposed to check it. So they plugged it back in, and they did 4 times 7 plus 8, and then they subtract 4 equals 8. And we want to check if this is true. So this is 28 plus 8, which is 36. And then you would, and I'm not going to do this every time. I'm going to tell you that right now. I'm going to double check in my head a lot, okay? This would be 6. 2 times 6 minus 4, is that 8? Well, that's 12 minus 4, which is 8. Okay, so that's checking it. You plug it back in, make sure that the thing is actually a solution. There are times when we get answers that are not a solution, right? Sometimes we'll have more than one, and sometimes it'll just be one. Okay, I'm not going to go, this one's probably the hardest one. I'm not going to go through this one right now because I feel like we need to try some together here. And just checking and reading over someone else's work isn't what's going to do it for us. So let's check this out. It says solve each radical equation by using algebra and check your solutions. How do I get rid of the square root? Well, what's the index? 2. The index is 2. So we're going to square it. We're going to square both sides. And this is really easy now because that gets rid of all the messy stuff. And we have 2x plus 3 is equal to 25. Okay, next we're going to subtract 3 and get 22. Divide by 2 and get 11. And I'm not going to write all the baby steps in between, and I don't mean baby. If you want to write them, that's totally fine. It's just we're in Algebra 2 now, so I'm not going to need to show all those little details that I say. Okay, this one's got a power of 1/5. What can I multiply 1/5 by to get rid of a fifth and make it a 1? You know, turn it and multiply by something to get a 1. 5. So we're going to take it both sides to the 5th power. And that's going to get rid of the 1/5 and the 5. Those are cancel each other out. We'll have 4z because they undo each other. And then I got to find out what 3 to the 5th is, and that's 243. Because I have it memorized. You can use your calculator. Isn't it 243, right? Because it's 81 times 3. I memorized 3 to the 4th, and that helps me memorize whatever, 3 to the 5th. So next I would add 1, divide by 4, and z would be 61. And now you might be saying, or if anybody is, are you wondering why there's no plus or minus? Okay, did I have a squared term? Did I start with an x squared? No, I have not, so that's why there's not 2 answers. These are roots. Roots don't give us an extra answer. All right? Because if you're taking a root, it's just the principal root. If you start off with a power that's even, then you get doubles. Okay? And we'll talk about that again in just a minute. So we're going to subtract 3 on number 4. We'll have the cube root of 4y equals 2. Now we're going to undo cube root by cubing. This is why we've learned some properties of exponents before solving these, so we can understand solving them. All right, so then we cube both sides. We get 4y is equal to 8. We divide by 4, and I forgot to check these, and I better go back and discuss that. Put in, and we get 2. Does 2 make sense for this? If you plugged it in, does it look like it's going to be a problem? 4 times 2 is 8. The cube root 8 is 2. 2 plus 3 is 5. This does check out. So let me go back a moment since I didn't check these two and talk to you real quick about that. I got a positive 11 here. Usually if you get a positive answer, you're pretty safe. Sometimes it's when you get a negative one. You got to be real careful. If I got a positive 11 and I stuck it in here, 22 plus 3 is 25. That's going to work out fine because the square root of 25 is going to be 5. So this does check out. If I went to this one and put in 61, all I'm going to get is 243 in here, and that's going to give me to the 1/5 is 3. So these did check out just to make sure I didn't not bothered to look at that with you. So let's get to number 5. Ooh, we got a doozy here. We got a radical and a radical. Do not write down what I'm about to write. Don't write it down. Do not. Don't do this. No way, Jose. This implies this times this times this doubled, and this times this. It's like you have to FOIL it out. Okay? So when this happens, what we need to do is isolate one of them, which will isolate the other. So what I need to do is actually add the square root of 5x minus 4 to both sides. Okay, so that's going to give me the square root of 21 equals the square root of 5x minus 4. And now that I have the radicals on either side, I can square both sides. Okay, we get 21 equals 5x minus 4, and then we add 4 and divide by 5. So we get our one solution of 5, which is fine. Okay, this one, you better watch a second as you're trying to leave, that you have to go early. Square both sides. Make sure you square both the number on the outside. That's the biggest mistake commonly. So that's going to be 4 times x plus 11 equals x plus 2. I cannot say I won't be glad when this is over. Thanks, guys. Have a good one. See you. Be ready tomorrow. Distribute here. 4x plus 44 is equal to x plus 2. Subtract x. Subtract 44. And divide by 3. I think I get a negative, right? Negative 14. Uh-oh. I warned you, if you get a negative, be sure you go back. What's going to happen if I put in negative 14? I'm going to square root of negative 3. Your calculator even will tell you that's a problem. Oh, there it is. Square root of negative 3 creates, it's an error. It's a non-real answer. All right, so no solution. You can't fit it in the original equation. Doesn't work. That problem can't be solved. There is no solution that will work that's a real answer. There could be, but no, we're usually getting a number that we have to check. Okay, and let's just get this one done. We're going to add the 4th root of x to both sides. And then we're going to take both sides to the 4th power. We got 625 equals x. And that checks out just fine. Still have a couple minutes, so hang in there. All right, no, we're not done. Divide by 3. You do not need an opportunity to line up at the door. I'm not done. Divide by 3, and we get 81. Now, what are you going to do this one? We got a 4/3 exponent. So we need to take it to the, just redo the reciprocal power. Okay, now that's better to do, but notice this, guys. Does anybody see this? I wanted to bring this up because I said something earlier. What's that top number? The power is even. Plus or minus. The power is even. Plus or minus. It's the only one we've had that had a power. Top number is even. Okay, so we get 2 answers. So 4th root of 81. Oops, I wrote that goofy. The 4th root of 81 cubed is what we're going to be getting. So what's the 4th root of 81? So it's plus or minus 3 to the 3rd. So that's plus or minus 27. You do have an assignment on this, but you'll be able to work on it after your quiz tomorrow. And I'll do these a few before, because we did have a few we didn't get to because we had some disagreements that we had to discuss. That's all right. I'm going to finish them up actually after this. If you okay, I'm going to quick do these last problems that I didn't get to do during the class so they can look them up. Subtract 6 from both sides. We got the cube root of x is equal to -5. And then we're going to need to undo the cube root. So we're going to cube both sides. And that's going to give us x equals -125. Now, if we substitute that back in, that is fine because you can take the cube root of a negative. That would give us the cube root of -125 plus 6, which is -5 plus 6, and that does equal 1. So that does check out.